Welcome. Yeah. I wonder if I would have the same crowd if it wasn't for the keynote last night. A lot of people are interested in learning more, and yeah. But I'll say it now. This is not going to be a replacement for Dr. Ao. I actually got CCP Recurve to take some economics stats together, which I can do after. Just briefly go over that after this session. But I'm not the economics expert, just saying that now. I'm data and analyst. Um, but we'll still show it here. Now, this is going to be, I'm going to go over data science behind EVE Online. This is what any game company is doing these days, really similar things. And the focus is on using R, so I'll be, just for the sake of, for those who are using R, I'll be mentioning which packages we're using for analyzing and plotting and manipulating data. And let's just get started. So I'm CCP Quant. I don't know if you guys maybe saw that link and already opened that in your mobile devices, but this presentation, this is also a test by me, and I'm using that reveal.js, so this is all made in HTML. This isn't PowerPoint. And so this is resolution independent, and you can open that presentation and slide through it on your mobile phones right now. Which means you have all the graphs also. You can download them. Our team, data team here, they are actually sitting in the audience. It's CCP Circon. You can, if you want to apply for a job, you can talk to him. And CCP Extricate, he's our senior data engineer working on building our data warehouse. And yeah, he's an expert in data, all the foundation that I build on. And then CCP Khan is a data engineer. He's actually not here present right now, I think. Unless he stands up now and says, yes, I'm here. Nope. All right, let's get started. Now, going over the data platform and the EVE Online data briefly, taking two cases of analytical projects we've been working on. Visualizations with some emphasis on visualization. That's going to be the largest part. I don't think you're going to complain about it. And then some Q&A. And I think I usually use the full time on presenting, so maybe we have the roundtable immediately following this presentation, so just come there, and if you have any questions, we can just hopefully answer all of them there. Yeah, and every single graph you'll see here is made in ggplot2 in R. Now, it all begins with data, and this is the PCU. Guys, this is data that's already available online, and it's averaging around 41,000 per day. And there's some seasonality. If we plot it by months, we can see it's somewhat lower during the summer months. Obviously, people are maybe getting some tan instead of being in EVE Online, and I can see that by activity in EVE Online. User estimates for 2014, it's, as I said, 41,000 PCU usually per day, 175,000 users per day that log in, unique, and 420,000 per month. And the state, the combined state of EVE Online on TQ, this is an SQL Server database that's presently at 2.5 terabytes. And the largest tables have to be archived regularly for performance reasons. And that's at around 3 terabytes, so 2.5 terabytes in all in user state. Now, as you saw in the keynote yesterday, we have a lot of logs that get generated. Around 300 million lines of log records generated every day. And as I mentioned yesterday, it's around 50 gigabytes of uncompressed data. There's quite a big difference between weekdays and weekends. actually 21.7%. And accumulated, this is around 25 terabytes of compressed data. And the compression ratio is around 1:8. So this is quite a bit of data we have to go through when we want to build up some historical graphs like I showed you on the keynote yesterday. And then if you make some errors in your code, then you realize you have to do it all over again. Yeah, I had to do that, not once, but 3 times. And this is where Hadoop comes in. We use Hadoop to do this, map and reduce framework. We have around 15 computers in a cluster doing that. So these flat log files are processed in that map and reduce framework on the clusters. R can work directly with Hadoop through an R Hadoop package, but we use Python to implement map and reduce functions. Or Hive, this is kind of like an SQL-like syntax. It's called HiveQL or HQL that allows to query the logs through an SQL interface, kind of. And then we have this even matrix. This is where we take data from either a state or from Hadoop and we aggregate it and put that into some counters. And this is what game design and people working on EVE Online programs, they use EVE matrix extensively to, for example, track how features are being used, how you guys are reacting to changes. And so how do we take advantage of all this data? There's segmentation, as you saw last night. We can identify player stereotypes in EVE, grouping players by play styles. Can we identify gameplay elements affecting, for example, onboarding of new players or retention of established players? Can we predict how the in-game Plex float is going to progress through the year? Or given a list of behavior variables, can we predict the likelihood of players leaving EVE? And maybe keep them from leaving. And often, and this is going to be a big part of the presentation, a lot of the analysis can come simply by visualizing data. I'll go through that. And beginning with the player segmentation, the segments you saw in the keynote last night, I'm going to go a little bit into detail on how that was made. It can be quite technical for some. I don't want to bore you, but still I don't want to oversimplify things. The goal was to identify clusters or groups of players based on their behavior, to better understand how players are using EVE, and to create profiles to keep communications with them optimal. For example, if we are making newsletters, then we don't want to be giving the aggressor a lot of information about how the industry has changed. We want to keep them updated on the PvP elements of the game. So there are a lot of good things for us to take from this as well. And the implementation of doing that kind of thing, first we brainstorm, make a long list of variables. We just for example, how active you're in shooting other people's internet spaceships, how much you mine or produce, how much you socialize, how much you travel, the number of jumps you make, how often you log in, and how long their game sessions last. And then we individually analyze and transform all these variables. For example, we look at the distribution, and some can be log transformed or factorized into ranges. And in the end, all variables are normalized into ranges from 0 to 1. This is to make the clustering and the principal component analysis stable. For example, if a player did some mining in January for 5 days, then the mining variable will be 5/31, the number of days in January, giving us a mining value of 0.1613. Now, then we select the most important variables. This is an iterative process of doing principal component analysis, segmentation, and discussion with in-house experts. And then we use the principal components to, PCA to perform dimensional reduction, find the optimal number of components to use in the clustering. And we ended up with using the first 5 significant components. Finally, running that through a k-means clustering algorithm. and pick the optimal number of clusters to settle with. This is the number of segments we end with. Look at the underlying variables aggregated by cluster IDs and come up with fancy names of them. Because the output of the clustering is just you have a list of clusters with IDs on them. So we go and each and every one and we look at the underlying variables and see what's the weight of all these variables for the clusters. And every month we update the segmentation and do histograms like this one here and compare how the distributions of all these variables is changing so we can identify issues with the data. I mean, this isn't really a clear graph, it's meant to be, but you might be able to see that in some cases where we factorize into ranges, or so it's low, medium, low, medium, high, or high, or something like that. And as I said, we ended up with 6 clusters, and when you have to decide the number of clusters you want to go with, there are numbers of methods. What we used is observing the total within cluster sum of squares of every added clusters. If you haven't taken advanced statistics or worked with clustering before, you will have no idea what I'm talking about, so it doesn't matter. Nor would you be interested. And for presentation purposes, it can be useful to visualize the clusters. And so, as I said, this is 5-dimensional. If we want to visualize 4 dimensions, that can be hard unless we can use the 4th as a color. Or if you're visualizing 5 dimensions, that's next to impossible unless you can, if your 5th dimension is time and you can do an animation of the graph or something like that. Here's an animation that should actually be playing. Why isn't it not playing? Play. Yes. All right. So this is just taking these clusters. This is actually from the output of the cluster, sampling closer to the centers of each cluster, and just visualizing the clusters. You might see that there are 7 clusters, and the orange one and the dark orange one, that's the traditionals I talked about yesterday. And the difference between those two were traditionals that did trading and traditionals that didn't do any trade. And we decided to merge these as we didn't think it was important to distinct between them. Here you have this one here. This is the same graph as you saw on the keynote from yesterday. I'm not going into detail again over how all these variables work together with the segments, but probably some of you might notice that there's an additional segment there. This is the passive segment. And the passive segments are those that are they're completely stopped logging in, playing, and everything. They still have an active subscription and are very likely to. So this is basically your final bus stop. So we have to, when you go there, we'll get worried. And here we can see these clusters by on the x-axis. You can see mean tenure, and tenure is how many months players have been playing EVE. And the mean minutes played per day in December 2014. And this is just the total login time divided by 31 days. And you can see just how much professionals play. There are 3.5 hours per day. Entrepreneurs are 2 hours and 20 minutes approximately. Aggressors, social players, and traditionals around half an hour to an hour a day. As you can guess, the passives are at 0. And what did we learn? Professionals, entrepreneurs are very active, playing almost every part of the game. They're the backbone of EVE Online and very valuable to us. Just as to the health of EVE Online, they're keeping the wheels running. And many players mainly play the social element. This is where we can really improve. A lot of players seem to be really happy with that, and we at some point might be able to come up with solutions of making some features available through mobile clients. The passive segment, as I said, that's the last bus stop, and we keep a close eye on the amount of players transitioning into the passive segment, and also the path. You never go from being a professional into a passive. You go from being a professional, then you get tired of something, you might go into entrepreneurs and then into being a traditional, finally social, and then passive, and you go. So this path we keep an eye on. And that's it for this. The only external packages we used for in R was this factor miner. It's the state-of-the-art factor analysis and principal component analysis in R. Next is decision trees. In our segmentation, a player will first get a segment at the first 3 months of playing. This we call the onboarding period. In the first 3 months of new players playing EVE Online, what behavior during that time contributes to them still playing in month 4? So the implementation of this, we reuse the existing database we have already created for segmentation. That's a good summary of all your activities. And we aggregate them for the first 3 months of tenure, add a response variable, are you still playing in month 4 or aren't you? And run through, it's a function in R called rparted, which is a partitioning tree function. And a minor detail, these graphs were not made in ggplot, but yeah, you might notice by how aesthetically not pleasing they are. So I started with, this is a tree depth of 4, we have more variables in it, and just I want to zoom in into these here. So the most important variable deciding on whether you were still playing in month 4 was whether you got your ship destroyed by another player. And followed by the size of the corporation you joined. If you didn't join a corporation, you didn't have a high likelihood of, well, you have you're less likely of still playing. The bins here you see, maybe I should explain them a little bit. The dark gray patches, that's a ratio of players not playing a game at month 4. The light gray is they're still playing. So the more light gray, the better. And so, sorry, losing a ship to, this is yes to the left of your graph. So it's losing your ship was good. So you lost your ship, we go to the left side, which is amazing. I actually thought it was the opposite, but we'll cover that. Like, and as you can see, that if you didn't join a corporation, you had about 65% chance of not playing the game after 3 months. Small corporation, you are at 50%, 45% medium corporation, and slightly worse if you joined a large corporation. But yeah, and mining, if you didn't get your ship blown up and didn't do any mining, you had 98% chance of leaving. And I'm gonna explain this a little bit. So getting killed by another player being the most important variable. So let's just route them all through Rancher or Amameg. And then just reap the benefits. Everyone's gonna start just playing EVE. We're gonna stop seeing new players drop out because the game is too hard. Not quite. So did the player get killed, which caused him to love the game, just finally see what EVE was about and just keep on playing even more? Or was the player already on a path of an active player, joined brand newbies early on, eventually you're going to get killed? So correlation doesn't imply causation. We can't state that going into low sec or getting killed is going to get you to stick with the game. We just see that those that stick with the game, they get killed. But, you know. So then management will ask, all right, why are we doing this? This isn't telling me anything. How is this actionable? The decision tree gives us a list of variables that we can take and perform A/B testing. We can send 50% of players through Rancher and Amemege, do a tutorial that ends there or something. And we can do something different with the other group. And then compare the retention rates of the two groups. And we've been doing this for, well, and not this thing. We thought that was just silly. But we experimented with letting new players, whether they started in the hangar or in captain quarters. There was absolutely no difference. As Andy mentioned on the keynote yesterday, the new what's it called? Opportunities. The new opportunity system is really promising. It's showing that players are far more likely to stick with the game. So this is how we are building features now. We're first seeing if they matter, and if they do, they stick with the game. We're not just blindly doing stuff anymore. Yes, I already covered this one. Now, visualization. Often we can come a long way simply by presenting data in appropriate, intuitive ways. I want to take this as an example. Find an optimal time of day for our downtime. So I was asked, if we were to move downtime, what would be the best hour? I made this graph, and if there wasn't that downtime, you can see the dip there, that's obviously downtime at 11. If there was no downtime, you'd see a really normal sine curve, basically. So you could speculate that the optimal downtime would be in 6 in the morning, at least in your perspective, because we're not going to get our engineers to be at the office at 6 in the morning. I mean, if something goes wrong, you have to have all the people and stuff. But we know at least in which direction we would move the downtime if we were to do it. It would be then maybe at 9 or 10. Another case I got this request from one CCPer. Fair request. Those are random numbers, but what he was after, this is what he had in mind. He wanted to see the relation between the account age and the actual age of you as a player. And I gave him this. This is a heat map. On the x-axis, that's the player age in years. And the y-axis is the account age in years. And you can see just this gives you a really good, like if you could read the labels, it would give you a really good idea of where the density lies here. And of course I made an animation out of it, and why not? Let's just never not make an animation of it. Rolling through. We're adding years. This is as EVE Online gets older. Staying the same pretty much. No dramatic changes over the year with this in mind. And since we're on the topic of age, yes, this is a classic one. There's been a lot of speculation on how old EVE players are. Many people think they're far older than other players because of this learning curve, and only the old and wise can stick with the game. And to put all this to rest, I posted this on Reddit. Some of you or most of you hopefully saw it, and it got a lot of feedback. It actually got 1.5 million views, and I just loved all the discussion around it. I even learned a new statistic. There's one statistic missing there, really basic statistic I myself had never heard before. I mean, I had the quantiles, I had the averages. There's one statistic, the most frequent number being age of, what was it, 25, and that's called the mode. Never heard of it before. Just somehow missed it in my studies. Yes, there's always something to learn. But do you think, now I took the same data, plotted with the default histogram function in R, do you think this would have gotten the same attention on Reddit? I seriously doubt it. Or ggplot to be fair here, because that's the package I use. That's the base ggplot version of it. Still, I don't think it would have gotten far. Of course, there's a lot more code to make it so fancy, but I mean that's that's how it is. Then I made this video. I am not, due to time, I'm not going to scroll through it. As I said, you all have the link to the presentation. You can go through it. All the links are there. But it can be summed up with a simple graph like this, showing over the years how the age of when you first joined EVE and how old you are now, how those distributions are going away from each other. And to show you endless possibilities of ggplot, because there's not a function that allows me to, for example, this one here, we have the event logs that I started with. This is another way of looking at time series like this. This is a calendar view, calendar plot. There's not a function called calendar plot. This is something you have to make all these data frames and just plot it, every single element. But ggplot makes it really easy. Here you can really see, I don't know how clear it is, but you can see that, for example, during the weekends, that it's far more of events that get generated. And then you can really quickly not only see some outliers, here are really few events generated, and you can see exactly which day it was in which year and what month. And that kind of a thing isn't possible with this one here. Well, it's really hard. You have to, all right, there's an outlier here, what date is it? So obviously the scale isn't granular enough, so I would have to go in the data. But here you have this one here, really on a daily level. And you've seen this one here. This is just another heat map. We can do this for so many things in EVE, and I'm at the tip of the iceberg now. I'm surely gonna keep doing more of this. The damage profiles here by ships and by the weapon types as well. This was released on Reddit and Twitter as well. And we can do some 2D density estimates. If I recall correctly, then this is the total mining volume in the EVE Online universe. 100% stacked graph of EVE Online players by yearly cohort. I showed this to Hilmar and he said, Eddie, just don't show this, people won't understand it. And I mean, it looks fancy, that's why data is beautiful. But this is showing how every year we get a layer of new players within that year. And they stack on top of each other like an iceberg. And at the very right side of the graph, you can see that 50% of players of EVE Online now came here 2012, 13, 14, and 15. So you can see just how all these new cohorts of players are adding to it. So if you're here since 2003, you can really see the bottommost layer, that's you and players coming in the same year as you. My cousin is here in the audience, and he's one of those. EVE Online players by country. US 35%, Russia 12%, followed by Great Britain and Germany. And what we in Iceland do to win at every country-related metric. Yes. We just normalize by population. And this is good because we can then brag with our Scandinavian friends because they also are there. We have the Faroe Islands at second place, Denmark, Norway, Sweden, and Finland. I actually think if you Google internet penetration, just what's the percentage of population with internet access, then you will see that these countries are by far highest in the world. So I think this is what that is. And ratio of players in each country attending Fanfest. So it's of all the EVE Online players in each country, how many are on Fanfest? Iceland, so I made it pink because I'm not going to count it on this scale. CH, which many people think are China, exactly, Switzerland, and Norway, Sweden, Finland, Great Britain. Then we have NPC kills by wormhole class. Wormholers will love this. The CSM has had a glimpse of some of these graphs. A lot of the kills are in C5, followed by C3. Ship deaths. This is something I was just playing with, just the ship death profile by wormhole class. Control towers by wormhole class. So you have their C2 at the very top, followed by C5. And a bit off topic, D3JS. This is something, it's a similar nature as ggplot in R. And you might remember this one here. And unfortunately, I don't have an updated version, but it's coming soon, TM. But I mean, it's, yeah. Still, it's the link I provided to the source code for this kind of a graph. So if you wanna see how this gets made, you can just go and browse the source code, play with it, and update the graphs. Just briefly over the tools and packages. This, yeah, I'm not gonna spend too much time on this. This is, well, maybe this one here. This was at some point, I think this was in December, at the end of December. This is the growth by country in over the past 60 days. We had a huge bump of players coming, and I mean a lot of trials, and they went out. I just want to go into the graph simplification here. This is a basic GG plotting. You remove the legend, just remove all the noise, go from an ugly graph into a just plain graph with simple lines that's readable. And people won't have to, I mean, you don't need a vertical scale or things like that to understand what's going on. This is inspired by this one here. You've probably seen it. Less is more. This is pretty much what I try to go by when I make graphs. These default Excel graphs, or all these default graphs, to taking them and just simplifying them down to have try not to sacrifice information, but try and make it clear. Some more, this is available in the slide deck that's available online. You can go through it. Not going to spend time here. Thank you very much. Now, before taking questions, as I said, I talked to CCP Recurve about getting us some economics data. And again, as I said, I'm not the economics expert. And CCP Recurve is presently our only economic expert, and he is home sick, probably watching this. So I'm going to go through it. This is the main price indices of EVE Online. This is since the beginning. And I think Ayo is here somewhere. I don't know if it's in the audience. No, unless he's hiding. I don't think so though. I mean, it would be great to get him as a guest lecturer here, but yeah, I'll just go through these here. Inflation since 2013. People complaining about things being so expensive now compared to a few years ago. I mean, this is the inflation you see. Pretty stable. The ISK, total ISK in EVE Online, by characters and corporations. The biggest ISK sinks and faucets. So the biggest faucet being, of course, NPC bounties, followed by commodities, incursions, mission rewards, insurance. Then we have against them, we have the LP store, the skills, transaction, tax, blueprints, broker's fee, manufacturing, and sovereignty bills. A net ISK inflow into the economy. And that's it. So going back to this one here, I have this fancy animation for taking questions.
Can you put the URL for the slides up again?
Yes, absolutely. Let's see. So glad you asked, because then I get to show you this really fancy feature of this stack thing. See how multi-dimensional this is and beautiful. All right, there you go. This is a link to the slides. And we will then publish the economic slides as well, so you can have access to it. And hopefully, I am working on trying, or I will work on trying to get these numbers into our EVE metric system, so we can regularly give you guys access to these numbers instead of doing it only on Fanfest or something like that. And of course, the hope is that you guys will be able to make your own economic analysis. As you can see, we are working really hard on getting more data available to you guys. The character history aggregates, as you saw in the keynote, and the market data exposure in the crest endpoint. We are working to get more, and the consumer price indices and ISK flow and things like that. No promises though, but this is what we want to do. Any more questions? We will have, yeah. No? Yeah?
So, do you have a good suggestion for where to start if you want to start learning how to do this stuff?
Yes, I actually do. Let's see. Here I at least mentioned tools and packages. Start by getting R and R Studio. And then it's the main packages of R. No one really is using, so R has some core functionalities, but some are just too old. They've been replaced by new packages that are often created by kind of the leading people in the industry in that area. Like the guy who, I mean, the almost, yeah, what was his name? This guy was, I actually have his packages here somewhere. Let's see, it was the forecast, Rob Hindman. It's kind of the leading guy in time series analysis. This is a really good package to use if you're doing time series analysis. And then it's this factor miner. The guys behind that, they are at the top of their class in doing principal component analysis. And then we have, SQL DF. If you know SQL and you're working with data frames in R, then I'd suggest using SQL DF to get started, because this allows to use just basic SQL to query, join, and do, not even basic SQL, this is complete SQL syntax that you can use in R on our data frames. Data table is really good for having huge amounts of data. I usually load a lot of data into just memory with data table, and it's just extremely fast for aggregating large data sets and filtering, and yeah, that's, yeah. And then of course, if you have some interesting data to work with, that's, of course, you have to start there, but I recommend just getting R Studio and start hacking. Okay, any more questions?
Before you get it into R, before you get your data into R, do you do any sort of data massaging, like, and what tools do you use to do that?
Yes, it depends on where the data is coming from. If the data is coming from a database, I try to aggregate as much as possible without sacrificing, well, without sacrificing details that I need in the analysis. So I try and limit the amount of data that I have to read from a database. I do a lot of the data preparation in SQL then, if it's coming from a database. A lot of it, like the log files, we go through it with map and reduce with Hadoop. So because we have all these logs, as I said, 25 terabytes compressed, and we use map and reduce. It takes about 40 minutes to go through it all. It is just amazing, and that's in Python. So doing map and reduce in Python, and we get that and kind of piped into this Eve metric system we have, and I read that into R from there.
How many log files do you have totally over the years collected?
Log files, how many?
Log files, log lines.
Log
files.
I'm not. I didn't check that. I'm not sure. It's 25 terabytes compressed. So yeah, I'm not sure how many log lines there are, because and also we are. It wouldn't tell you. We are always adding more logs. You're always finding, oh, we should have logged this and that, and we're just adding more details to our logs.
About 300 million per day?
Yes, 300 million per day, and yeah, so and that's pretty stable for actually. Where was it? Where was it? Yeah, 300 million per day, and this is pretty stable for the past 2 years. So that, yeah, that gives you a picture of how many lines there are of logs. More questions? I saw. Can you pass the mic for the stream? Okay.
You mentioned going through everything takes about 40 minutes.
Yes.
What's the sizing of the equipment you actually use to do that? How much compute power do you have?
Yes, good question. Well, let's see, where was it? Good to have all the replies just in my slides. Yeah, 15 machines. And this
and what's
is
in these machines?
sorry.
And what's the sizing of these machines? I'm thinking like concretely. What do you run this on?
Machine specs. Not sure. Do you remember the machine specs of the new machines though? No. Well, I'll try and get back with you on that. We are actually in the process of getting our own. Well, this is in. Yeah, getting a new one, getting it even more powerful, because ultimately we want to be able to process these logs and feed them back into the client or something like. Well, not the client, back into Eve live on TQ. For example, track. Yeah, I won't go into details, but yes.
Thank you.
What's the most surprising statistic I've ever come across? That's a good question. At the time, I can't think of anything except for the other day I was looking into. Yeah, it's a shame I don't have that graph, but I wanted and I wanted to include this in the keynote. Just how you guys are fast to adapt. You know, we remember we updated. Well, we changed the distance from where you spawn after you jump through a wormhole. Capital ships, so it's mass related now. So if you're in a capital ship, you might end 40 kilometers away, and thus the total number of collapses of wormholes went down significantly. But then it just gradually went up to the same level. So you guys just adapt. I think it was interesting to see how quickly you guys adapt. So after a month or two, you already adapted and just changed your how you do collapses, and this is no longer an issue for you guys. So that, I think it's fun to look at data like that, but nothing there's with the large quantities, there's nothing that quickly comes to mind. Yes.
So do you have a simple question that you think, oh, the answer has to be here in this data somewhere that you haven't been able to answer? Like, what kind of question would that be?
That would be, we are always looking into finding what it is that clicks with new players, for example, how they are when they first go into Eve, what paths do they take, and that cause them to like Eve so much. We have so many variables to go through, and the complexity of the data is also great. So we haven't been concretely been able to map it out, like find some really interesting variables there. So we're still working on that. And before the keynote, another example was I hadn't before the keynote, or no one in the keynote, or before the keynote, no one at CCP had seen damage on this scale before. No one had been realized before what the damage of structure damage was compared to other damage in the game. Everyone knew structure grinding was a problem and players were complaining about it, but this graph I showed on the keynote yesterday, that was new to everyone. And when I made that, I wanted to tell that story, and I was so hoping for that data to come up. Like after having to go through all this data and spending days to get data to the format I needed, and then seeing the story in the graph finally, that was such a relief, because otherwise I would have had to find something else to talk about. Right, we are out of time now, and this is now immediately followed by the roundtable down in Rennes, so we can continue this there. Thank you very much.